Ready? Louis? I'm sorry, let me, you can, why don't you stand over there and then,
Me?
yeah, and then I'll welcome you over. Because the frame is very small, and it's better, it looks better if we, all right, we ready? Louis, we're ready? All right. Good morning and welcome to Cloud Expo Day 2 in New York, November 13th, 2018. Welcome from around the world. I'm Roger Struckoff, Conference Chair. Maybe you know that if you were here yesterday, but welcome in any case. We're going to start today with a presentation by Rami Radi, who's a Senior Software Application Engineer in the Data Center Management Solutions with Intel. And he's going to talk about when the clouds part, which I think is appropriate, you know, for Cloud Expo, right? When the clouds part, how to better manage your cloud infrastructure. Rami, take it away.
All right. Thank you very much, Roger. Good morning, everyone. Like Roger introduced me, I'm a Senior Software Application Engineer. I work in Intel's Data Center Management Solutions Group, and I work with customers, including HPCs and other data center based companies, and help them adopt one of our solutions called the Intel Data Center Manager, which I'll be talking to you about today. And the whole idea is to help them optimize the performance of their data centers, monitor their health, and optimize their energy consumption and lower their costs. So for today's presentation, I first plan to share with you some statistics and some interesting tidbits about how critical it is today to have real-time and on-demand visibility into your data center performance. Then we'll talk a little bit more about the Intel Data Center Manager as a product. I'll share with you some of its features and functionalities, and I'll also talk to you about some use cases that it's been useful for, whether you have a completely cloud-based infrastructure or a hybrid infrastructure where you have some actual physical servers that you have to maintain and manage. And finally, we'll take a look at some case studies that might be interesting for you, especially some of those by CSP customers and industry partners that we work with closely, and that's going to be it. So lots been said about the data explosion that we've been seeing in the past decade, but I want you to look beyond these figures and numbers and statistics and think about all what it actually means. So this is all data that is stored in the cloud or in data centers, and this data needs to be processed, analyzed, indexed, searched, etc. So that introduces a big challenge to Intel and the whole industry, but also big opportunities too. So one important thing to know is that data center energy consumption accounts for almost 10% of the world's energy consumption, which is huge. And from that, 50% of that energy consumption comes from server utilization. The rest goes on things like cooling and lighting, etc. And it's estimated that around 50% of all data center outages are actually, they cost those data center managers more than $300,000 per hour. And that's for a typical sized data center. And I'll show you a couple of recent examples on how bad that was in some cases. One other interesting statistic is how data utilization is around 30%. So which means that servers might be underutilized by 30% in a typical data center, which is staggering, meaning that there are zombie servers and servers that are actually doing nothing. But it's all not that grim. So 15% of all the power savings that have been made were by following some simple KPIs like better cooling techniques and other things that we'll talk about in a little bit later on in the presentation. So one example that's worth talking a little bit more about is the recent incident that Delta Airlines had a couple of years ago, where they had to ground almost 2,000 flights over a period of 3 days, which cost them almost $150 million. And that's because they had an outage in one of their data centers, on one of their few critical systems, and they had no fail-over process in place. So that's how much a business can suffer. So with that, Intel believes that there are 6 pillars for a successful data center management solution. First, it has to be real-time, and it should be able to manage the thermals, the power consumption, and the health of all of the components of your data center, not just servers, but all other ingredients, including networking devices, storage, etc. And I'll talk a little bit more about that in detail later on. Second is that it has to be cross-platform with all the different OEMs that we have. There should not have to be a worry about what provider you're using. So cross-platform is critical. Another thing is, like I was saying before, broad device coverage. So it should support UPSs, intelligent PDUs, SANs, NASs, etc. And also, it should take advantage of historical trends and logs to be able to predict and prevent future problems from even happening upfront. And it should be able to aggregate this data that it's collecting from all of its servers in a very easy to understand way and group them in ways that you can manipulate that data whichever way you want. And I'll show you some more details about that later on. And finally, it should be able to do accurate and dynamic power capping, which might help you increase your rack density. And I have a use case to show you about that later on. And that eventually helps reduce your costs and improves your overall data center efficiency. Okay, so what is Data Center Manager? It's a middleware with a web services API for data center management. It basically sits on one of the nodes on your data center, whether it's in the cloud or on a physical system or on a virtual machine. And it can communicate using hardware protocols like IPMI, SNMP, SSH, Redfish, etc., to talk directly to the hardware, whether it's the BMC like Dell's iDRAC or HP's ILO or IBM's IMM or Node Manager, etc., which makes it work and communicate directly with rack servers, blades, storage units, etc., like I was saying before, on the hardware level. So it gets telemetry data directly from the source, so to speak. So no agents are required. You don't have to install anything on every single device that you want to manage. And actually, the systems don't have to be even powered on. So as long as their management interface is connected and you can connect to them, you should be able to manage their health. So this middleware comes along with a console, comes attached with a console, a management console that does what I was talking about earlier, which is aggregate this data and present it in an interesting and easy to consume way so that you can take intelligent decisions. Not only that, it comes with an SDK to help you programmatically connect to those APIs in case you need to integrate with other third-party components for ticketing or operations management, etc. Okay, and one data center manager instance, one DCM instance can manage up to 10,000 nodes. So again, this is really low overhead and a very small cost to pay, especially the fact that it's agentless and out of bound. So with that, what can you actually do with DCM? So there's a bunch of things here. The most important ones are obviously automating the health monitoring of all the components in your data center. Again, this data center manager can be used also on a cloud environment. And we'll talk about that a little bit later, where you can expose some telemetry data and make some intelligent decisions like workload balancing, etc. Another important thing is it can help you with do better capacity planning. So if you know how your systems are organized in a hierarchy, which I'll talk about a little bit later, you can simplify and optimize your next server procurement process. And then regarding that statistic that I was telling you earlier, it can definitely help you identify dead or underutilized servers so that you don't have to pay for those indefinitely without the need to. Okay. One other thing is that it could definitely help you measure the energy consumption by device. So again, not just servers, but other devices in the data center. And you can use it to improve your thermal profile. So there are many cases where data centers suffer from inefficient cooling or inefficient temperature monitoring. And I have a use case to share about that too. And one more interesting thing, there's a white paper on that actually on the intel.com/DCM website, where we show how DCM eliminates the need for smart power strips. We have an example showing how much savings that could cost the company. So very quickly, let me show you a screenshot of how the DCM console looks like. This is, again, could be deployed in a virtual environment or on a dedicated node on in your data center. So you'll see a group of gadgets on your dashboard once you log in. And it will quickly show you how your data center is looking in terms of the number of systems that it contains, the total power consumption that it's using, how much power budget is left, other things like the highest temperature that any one device has reached throughout the day. So that would be a hotspot, basically, that's easily pinpointable. Other things would be, things like graphs of the power consumption trends or temperature consumption trends over time, whether it's over a day or a month or a year. And then you can set it up to set alerts and or set events and thresholds. For example, when a specific server reaches a certain temperature or a certain CPU utilization, etc., that would give you an alert to your email or text you, etc., for more efficient data center management. Okay. So this next screenshot shows how typical DCM instance would look like in terms of the devices that are installed in it. So you can add data centers, so you can have multiple data centers, each one with multiple rooms, and then each one with multiple rows and racks, etc. And you can even click on one of these racks. I don't have it here in this screenshot, but you can even show a heat map of that entire rack. So that would be a very easy way to figure out which servers have thermal hotspots. And thermal hotspots can be, due to many reasons. The simplest of them could be, something was placed on top of a ventilation next to a rack, and we've seen that actually in production environments where something that simple could cost a lot of money. Okay, and this is one of the other tabs, which is Intel DCM cooling analysis. So you can easily, like I said before, pinpoint areas where you might have inefficient cooling or thermal hotspots. One interesting feature about DCM is that it can help you also synchronize and make sure that the firmwares of your servers are all above a certain version. So in many data centers, you have a plethora of OEM devices, all of them of different generations with different firmware levels, and sometimes having inconsistent firmware levels can cause lots of problems. So DCM can tell you the details of each server in your data center with the model and the firmware details, and you can take intelligent decisions based on that. Okay, and remember I was telling you DCM makes sense also to deploy on a hybrid or cloud environment because it can actually tell you which systems you are using that are underutilized. So you can quickly, with the press of a button, see which servers over the period of a month or a day or a year have been underutilized below a certain percentage that you define, and you can again take action accordingly. Okay, so a couple of interesting use cases. The following ones would be more interesting if you have some physical servers that you need to manage. First one is the prediction and detection of cooling anomalies. So like I was saying before, in many cases you don't have good insights into how each system or device in your data center is actually behaving in terms of not just power, but also from a thermal perspective. And that's because you typically have just a few sensors throughout your data center, a few thermostats that are measuring the overall temperature of that environment. So what Data Center Manager does is, like I was saying before, it connects to the temperature sensors of every device on every rack that you have, and it can monitor them over time, and using algorithms and data prediction models, it can tell you as a system or an entire rack starts to reach a certain threshold. And when it does, it can alert you ahead of time so that you don't fall into problems and have issues like that Delta use case that I was sharing with you earlier. Okay, another use case about health management, which is, like I was saying before, almost all the components of a typical system are monitored by a data center manager, which includes the CPU, power supplies, redundant power supplies, memory modules, fans, etc., even batteries for the CMOS. So once any of the components are identified as problematic, an alert is sent out to you, again, like we explained earlier, for you to take action. So even fans, which could be the result why you'd see a thermal hotspot, a thermal hotspot might be because one of the fans are either malfunctioning or need replacement. So this is a correlation between both seeing a thermal hotspot and actually seeing a real-time component issue. Okay, this is one of the examples like I was talking about before, which is the replacement of a fan. So DCM would be able to monitor how a typical fan behaves over time, and based on that trend, it could alert you ahead of time that this might be a fan that's worth replacing. And this is just a little bit more detail about that server firmware synchronization feature that we were telling you about. This is actually a newer feature in our most recent versions. Again, having inconsistent firmware versions have a lot of consequences. not just in terms of the telemetry data that is output, but also in how a system functions. So it's a critical feature that we've added recently, and a lot of customers are using it. Okay, and now another use case on rack provisioning and capacity planning. So again, if you manage a physical data center, or at least parts of your infrastructure are physical, you're probably used to static provisioning, where you see that a server might have a 650 watt power supply rating, and then you use the safe bet or derated power supply, which in this case would be 400 watts based on lab measurements. And with that, you would be able to statically decide on how many racks you want, how many servers you want in that rack. So very quick calculation here, you would see that you would need 10 servers to install in that rack. But with DCM, you can use those trends that I was telling you about in terms of server utilization. And if you notice that your server utilization means that these servers never exceed 250 watts, you can plan the capacity and the density of your rack differently. So in this case, you would be able to stick in almost 6 more servers in that same rack. So you decrease the total number of racks you have, and that of course reduces costs significantly and saves you lots of space. Okay. Okay, but of course, if you do that, you might end up in a case where a corner case where some servers actually use beyond 250 watts, and then that way of provisioning might fail you. So with DCM, one of its strong capabilities is being able to do dynamic power capping, and with that you can tell on the rack level or the node level or the row level even that if a certain power budget is reached, you can dynamically change the power policies of those servers and reduce the workloads so that you stay within that power budget. Okay, so this is the case when you actually can exceed the rack capacity or power budget, and that of course could be fatal. But with DCM, like I was saying, you can put that limit, no matter how close it is to the rack capacity, and like I said, you'd be able to reduce the power policies of these servers to act accordingly. Excuse me. So obviously, Intel Data Center Manager is a product that we've built over the past 10 years. We have a big list of industry partners that we work with. This is just a few of them. So of course, our biggest OEM partners include Dell, Lenovo, Supermicro, and others. And those actually, they take the DCM core and build on top of that. So with Dell, they call that xClarity. With Supermicro, they call it Supermicro Power Manager, etc. But they're all using the DCM core. So those are our biggest OEM partners in the industry, of course. But we also work directly with ISVs and other cloud server providers, as you can see here in this list. And we have a lot of case studies online on how much savings that some of these customers had by using DCM. Again, many of those use a cloud infrastructure, whether it's from Microsoft or Google or Amazon. And like I said, there's still a lot of benefits from running DCM in such an environment, because you only have to install it on one virtual machine as long as it has access to the rest of your virtual machines that are doing all the work, you can still get telemetry data such as CPU utilization, power consumption, and again, based on that, you can make decisions like distribute or load balance your workloads in a different way. Okay. So with that, I invite you to come to our booth. My colleague Ron and I will be there. We can show you a live demo of DCM in action. We can talk a little bit more about some of these use cases and see how it might apply to your business or your environment, whether it's physical or hybrid or completely in the cloud. And be sure to be with us at 1 p.m. today. We'll have a raffle for one of our Intel-based drones, so that should be interesting. Yeah, and I think we have some time left, so let me try to show you a live demo of DCM. Okay, yeah, so this is the main dashboard that I showed you earlier on, just as a screenshot. This is the live version of it. This is running on one of our data centers, or actually a couple of data centers. Let me show you the hierarchy here. So you see we have a data center here in Hillsborough and another one in Santa Clara. And as you dive deeper, you see the real-time information getting updated here per room or per rack. So for example, the highest temperature that was reached in this room was 35 degrees Celsius, but in this room it was 39. And then in each row and each rack, you can start to look at the heat map that I was telling you about before. So these are all the servers in this rack. Of course, they're all green, but if we had any thermal hotspots, they would have shown up over here. And you see for this rack, you see that the power and temperature trends over a period of 1 hour, 1 day, 1 week, 1 year. So you can easily pinpoint anomalies. And once you do zoom in into that spot, you can actually dive deeper and correlate that with CPU utilization and correlate that also with the workload that it was running on that time and take some decisions accordingly. So of course, adding systems here is really easy. I can go to devices, and if I click on add over here, I can give it a certain name and choose a certain type for it. Like I said before, DCM does not just monitor servers, but PDUs, UPSs, storage devices, etc. And I can also, instead of adding it manually, I can do an auto discovery or import for the servers or nodes in your environment. I just have to add a discovery task. And if I'm adding servers, you're probably going to be using IPMI. We're also supporting Redfish. And you can start adding IPs. And in this case, it will discover all the systems starting from the first address that you gave it till the last one. And if you're adding things like smart PDUs or firewalls, you probably will use SNMP. And we support SNMP versions 1 to 3, etc. Going back to the dashboard, let me show you a couple of more interesting things here. So, like I was telling you, one of the rooms reached 39 degrees, so that is pretty high actually. So let me go to that room, and I can see here the analysis, and I can see that one of the servers actually reached that temperature for 5.6% of the entire time it was running throughout that period. So if I click on that, I can see which device that was, and like I said, take actions accordingly. And this is the low the low server utilization section that I was telling you before. I have not set this one up to show the daily utilization patterns, but that's where I got that graph that I showed you in that screenshot earlier. One last thing that I wanted to show you, which was the events and the thresholds tab. So you can start adding a certain threshold for a certain row or a certain rack or a certain server in that rack. So if the condition is greater than, if the temperature or the power consumption or anything else reaches that threshold, it can start giving you that alert that I was talking about. Yeah, I think that was pretty much it, what I was planning to show to you today. If you guys have any questions, feel free to ask. Otherwise, feel free to meet us at the booth. And I apologize for my voice. I've been talking too long since yesterday, so that's out of my control, unfortunately. Okay, thank you very much, Joe.
Thank you very much, and thank you, Mayor